Hi, welcome back to Chadwick Model Railway. I'm Charlie. This week it's been building a fiddle yard, and this is how I've got on. Now, as the layout starts to take shape in the first few modules, I think it's just worth mentioning that I'm now 62 years old. Shocking, I know. But my wife and I agreed that we would stay in this house until I was 70. So I've got sort of, or then when I was 60, 10 years to plan and build the layout and get some enjoyment from it. And that was just a minimum. I mean, you know, we may stay till I'm 70 or 75, or when I get a knock on the door, let's say. But anyway, I wanted to build it in a modular manner. So if we do move house and I lose this lovely railway room, I can actually take things as a module and move them into, say, I don't know, a double garage in a new house. And to that end, the helix, which is roughly speaking 51 inches in diameter, will be independent of all the rest of the wiring. There will be sort of two wires that go into the main power feeds of the helix, so it's easily sort of disconnectable. Is that a real word? Real word? Disconnectable. So we could move house. And similarly, the next board that's going to go along here will be again a modular board. Now, you may recall from an older video, there used to be a piece of back scene in here which didn't really fit in. It wasn't a good match. It wasn't such a problem because the hillside came up here and you could lose it with the odd tree. However, this back scene now needs to go on the rest of the way down the wall. So I've been on to John at artprinters.com, and his back scenes, you get two in a pack, and they're 1.5 meters long. So what I've asked him to do, because the back scene I actually wanted, it was buildings at this end and not at the other, I've asked him to reverse print it, so it should go from some houses to many houses, the idea, because this area here, I'd like it to go up into the station, which will be similar to that one in Barnstable. So it will become more populated as it comes up. Well, here's the first board in place, and this was knocked up by the guys at DCC Train Automation from me, and I did a little bit of woodworking and installed the legs. Obviously I need some, it's actually made of pop ply, which is extremely light but very, very strong. Obviously I need some kind of underlay on it, and when I did the helix I used this stuff from Arbiton. It's XPS flooring 5mm underlay, and XPS stands for extruded polystyrene. It's quite cheap at £26 a pack, and I think that's for about 20 sheets, or you can pick up 2 packs for £40, and that's from Wix. But a word of caution, yes, it's XPS, which is extruded polystyrene, but someone mentioned in a comment that is it UV safe, because ultraviolet light can apparently decompose certain foams. Well, I haven't got the faintest idea. I did a little bit of research and couldn't find out, but at the end of the day, this isn't going to be exposed to a great deal of UV. It's in the fiddle yard and it'll probably be covered up, and the windows are quite some distance away, but I don't believe there's an issue. But please don't buy it and find out that yours is decomposing, because I really can't be held responsible should yours decay in time. And these boards, they're held together with M8 coach bolts, just a couple of bolts through here, lined up and drilled through, to give it its rigidity, but as I said earlier, to give me the facility, if I need to break these down, I can quite easily. Now here's the AnyRail file designed by Lee Stoddart, and zooming in, this is the fiddle yard board that I'm going to build this week. So just dropping the points into place gives me an idea of where to plan it, where to mark it out, and obviously to glue down the underlay. I've gone for the longest of the Electro Frog Pico points where I can. So it's 1, 2, 3, 4, 5 long ones, maybe 6, and one of the medium size, because I want to keep all the points on the board. The last thing I want is a point going across from one board to another. And then what I shall do at the far end is cut all the tracks short, so there'll be a bridging piece to get onto the next board. One other thing worth mentioning is this measurement here allows the tortoise point motor's clearance, and I'm able to have decent storage underneath here, because these really useful boxes I think are 13 inches high, so they fit under there marvellously. If you're a regular on the channel, you'll realise that I write most of my t-shirts off with glue, which is why I'm wearing something a little less valuable today. Anyway, what's this? PVA, straight from B&Q, nice and cheap, white wood glue. Trade name is Dial. So anyway, whack a load of this, and this stuff here has got ridges in it, so I'm gluing it down, ridge side down as it were, because that might give it a little more grip. And I've got some weights ready to hold it down while it goes off overnight. And obviously the main reason for this underlay in the first place is obviously to give stable running and also reduce the track noise coming off the trains as they make their way around the Fiddle Yard. Not that they're going to be running that fast. I mean, there will be a speed restriction, let's say, in the Fiddle Yard, so they shouldn't make that much noise in the first place. But it's always best to have a decent underlay to give you more smooth running. I can't believe for once in my life I've got the quantities right. How's my baby?
Bad, how are you?
I'm okay.
Right. Busy bee?
That's my wife just arrived.
Oh.
Well, it's now the following day and the underlay is in and it's good and it's well glued down. So where do we go from here? Well, before I start laying track, I thought I'd mention what about these four uprights, what their purpose is. Well, between these four uprights, I'm going to build an open plan baseboard, and that is, rather than have a solid baseboard base, as it were, to run along, it'll be a case of putting in vertical long and cross members on which to build up the landscape from there. And that way, known as an open plan baseboard, you'll have much more flexibility where it comes to landscaping. And here's an example of an open plan baseboard prior to the scenics being installed. And so hopefully at this end, where these lines come down and join up with the helix, it'll be much easier to modify the track bed as it comes in, and similarly on the other side as it rises up to the branch line station. So before I go any further, I just need to mark out where this main up line goes, and there are no points on this line. And the down line, obviously I need the first point here, and then that will fan out, as it were, into the ladder of sidings. Just need to pull it away a little bit, so I need to straighten this track here, which is only glued down as usual with Copydex, line all these up, and then using the good old Pico 6-foot way gauge, it's just a case of getting them right for the streamlined track, rather than this way, which is the set track. Right, now we can get this board away into a more easier workable position. Now before we go any further, I need to modify these Electro frog points, and this is by no means a compulsory thing to do, because when you switch the point, the current on the frog changes. But to improve reliability, what you can do is you can actually snip through these two cables here, therefore isolating this area. Then you need to solder a longer cable on the end of this frog wire and then connect that to the point motor. So when the point motor changes, it changes the polarity of these rails, the frog and these two rails here. But to do that, you must, of course, have cut through those cables. As I say, it's by no means compulsory. It just makes these things a little more reliable, because you're not then relying on power coming through the switch blades here. The other thing you need to do is to power up the track itself. Now, in these two areas here, I solder on my cables. And the way I do it is like that. So I solder them so that the longer tails are on the inside, and therefore I only have to drill one hole through the baseboard. And make sure you get it the right way around. Now, on the top of my layout, I always say it's black to the back. But now that the tracks have gone through a helix, it's actually black to the front. So I remember it now that the whole of the Fiddle Yard area now is red to the rear rather than black to the back. Just one of those sort of strange ways that I kind of remember things. So what I shall now do now is I shall strip off a bit of these cables, solder these on, cut through here, and then add a frog cable onto this little piece of wire. And then also what I need to do, because I'm using tortoise switch machines, I need to remove the spring. And before you even dream of doing that, make sure it's that you really do have to, because a lot of points need that spring left in, but for tortoise they don't. Removing the spring is quite brutal. They're not as strong as you might think they are. So I just tend to go in there with a pair of snips and give it a bit of a yank. And there we go, all nice and floppy, and the spring's removed. So the next thing to do is to do a little bit of soldering. Now I always get asked which wire strippers I'm using, because these are very effective. Well, that's the number you need to look up on the internet. I can leave no link to this, okay? It's just simply an RS 382-2847. Please don't buy it from anywhere else bar the company that comes up. It's not Radio Shack or Radio Spares, it's something like that. But don't buy it directly from the company, not from Amazon, because some people on there sell them at a huge markup. But these are brilliant. They're not cheap, but they're brilliant. Obviously you need to tin the wires. This is a cheap and cheerful soldering iron. I think there's a link in the Show More tab. And the solder I always use is 60-40 solder. I've tried other solders, and to be perfectly honest, I'm just not happy with them. This one is when I changed from the lead-free solder, it was like a gift from heaven. It really was a great step forward. Now I've just got to prepare the point, which just means a little bit of a scratching up on those surfaces. To give the solder something to adhere to. And tinning the tracks is quite straightforward. Just a case of applying some heat and get a reasonable blob on each surface. And then remembering which way around is which, I start from the outside and work in. And then after every joint, I give it a tug. And I always do the outside ones first, because then otherwise you can't tug the outside ones if you've already done the inside ones. Great, we are the right way around, then the black, and just repeat the process. And then finally on to the frog wire. A little bit more awkward, this one. Seems an awkward shape for it to bond, really. And then when you pull it, make sure you hold the base of it when you pull it, because otherwise you'll pull the solder joint out of the rail. So there's those 3 cables in. The last thing to do is remember to cut those little shorting links, because we've powered the frog differently. One. 2. Easy. So that's the job complete, all quite straightforward. I've removed the spring from the point because I'm using tortoise point motors. I've soldered on the track feed cables, again together, so there's only the one hole. I've removed the small Pico jumper wires across there, and I've wired on my frog wire. All straightforward. I've just got to go and do another 8. Now, as you can see, I've lifted this Fiddle Yard board up onto some trestles. There's the line that goes straight through. It's the up line up onto the helix, and that's glued in place with Copydex. Copydex because I don't want to use pins, so I'm trying to keep the transmission of noise down, and I've put a pair of droppers on that. These items here you might not be aware of. This is a pair of Digitrax DS64s, and each unit switches up to 4 points, or 8 points if they're in doubles, and those are the controllers that I'm going to use on this bank of points. And also on this end of the board, these are called BDL168s, and these are used in block detection for computer control. So as you can see, that first line, the Copydex, is just starting to go off, and it's now time to fit this first point. So here's the first point of the siding layout, and as you can see, I've drilled 2 holes to drop those cables through, but now of course we need to drill the hole where the actuating arm from the point motor comes up and operates the switch rails. Now the way I do this is I like to get the point in position, and I get a small pin and I cut the head off, and then what I do is I centralize these blades and then pop the pin in the hole and bang it in. So to make sure the point's in the right place, again I have to use those little 6-foot weigh gauges from Pico to make sure my spacings are right. And then I centralize these blades and pop that pin in the middle. Give it a tap with a hammer. Whip out these bits, take the point out, hopefully leaving the pin in there. And this is where obviously I need to drill my 10mm hole for the actuating arm to come up. Now I don't know if I can recall that Tortoise reckon you need a 6mm hole, but I always find that 10mm works for me, so that is exactly what I'm going to do. I might well tear some of this foam now, but that's no big deal. And there we are. So all I need to do now is tip the board up, fit the point motor and the point motor wiring, and then it's obviously then just a case of repeating. I thought I'd better get out my little vacuum cleaner because I was ridiculed in an earlier video for not having one. So that's the first point in and glued, and using those good old Pico 6-foot weigh gauges, I then install both tracks to make sure they're parallel. And I always use this track setter template, again from Pico, to make sure that the tracks are true. because the last thing we need is a set of tracks that aren't parallel and straight. And hopefully these are pretty good. So the next thing is to fit the first point motor. So looking at the underside of this board, we can see the 3 cables that are coming through, and the first one there, the green one, is the frog. Then there are the other 2, which are the power to the rails, and then we can see the hole I drilled for the tortoise point motor. And if I move the switch rail, hopefully you can see going from fully right to fully left, it's pretty central, and that'll be ideal for us to mount our tortoise switch machine. Now some people ask why I use tortoise point motors and not something, would you say, more modern, shall we? Something that's DCC capable. Well, I stick with these because they are just very, very reliable. I've never had a duff one, and you know, until they start falling over, I will stay with these. I believe in them. They're simple, they're easy to install, they give you some latitude with the armature wire. Yeah, I mean, they're great, and I choose to change my points, admittedly using the DS64 from Digitrax. This might seem an excessive amount of point motors here. There's actually 23, and I must thank a guy called Dave Curtis, who lives in the States, because he sent me these 23 at a bargain price, let's say. So Dave, I am extremely grateful, and thank you very much. So there we go, let's get on and fit them. I do make one modification to these, and that is I install the piece of piano wire that I use is actually 1 millimeter thick. It's slightly thicker than the wire that's supplied. I just like a little bit more tension on my point motors. So there we go, that's why I use tortoises. Now to get the point motor in the right place, Tortoise supplied this little template, so you put that centrally over your hole, and then with a marker pen just mark out where the attachment screws, where the attachment screws are going to go. And then I use a small piece of cork just to stop any noise from the switch machine coming through, and then I obviously screw this to the board with 4 small screws. It's worth mentioning these the 8 terminals on the point motor. The outside 2 are the 2 that power it, and if I put these 2, the blue and the yellow cable, onto a small smoke alarm battery, then hopefully you can see the point motor turn. As you can tell, it's a pretty quiet switch machine. So to explain these then, there are 2 different switches inside, and these 2 cables here are to switch the frog, so track power comes in on these 2, and it will go to the center one now, which isn't connected yet, which is to this the frog cable. The frog then will go onto that one there, and then these 3 cables here, I'm just taking these off as a standby really, just in case I need a mimic panel. So I thought I'd solder these on and then just stick these out of the way underneath the board, because they may well come in handy in future. I've shaped and inserted this piece of piano wire in accordance with the tortoise instructions, because it has a couple of small turns in it, and inserted the fulcrum. Now the fulcrum moves up and down, and that dictates how much throw the armature wire has. So if you wanted to throw it further, then you'll move it down, or less, you'll move it up. So what I do now is insert this through the switch blade of the point, mark it off, and then bring it back out and cut it. If you cut it in situ with something like a Dremel slitting disc, you put a great deal of heat into this wire, and that can melt that section of the point. So just beware before you do that. I've done it in the past regularly, but as I can reach it here, which is quite simple, I won't take that risk. So there's the wire in the right place, and just a permanent marker pen, easy. So not forgetting the goggles, it's back to our old friend, the Dremel with a slitting disc. And now it's just a simple case of screwing it in position. Now clearly you don't get extra points for neat wiring, but if you put it in and it is neat, it does make it so much easier for fault finding. I'm not sure if I've mentioned it, but every cable on this board is going to be 702. That's 7 strands of 0.2 millimeter cable. I don't need to go to a thicker cable because these runs aren't going to be that long. I mentioned previously about these cables here for a mimic board perhaps later on, so they're just wrapped up and pushed out of the way. And I've also soldered on now the frog cable onto the terminal on the point. Now it is possible that the frog feeds that come from track power could be on this terminal the wrong way around. And then when you switch it on, obviously if it hits the frog and it shorts out, you just need to resolder those the other way around. There is a way of doing it and working it out, but to be perfectly honest, it doesn't take 2 minutes in this situation just to shift the red and the black the other way around. I think this one's good, so all I need to do now is to fit another 8 and the points and the track all on top, so I'll get back to you when I've done. The last 2 points on this board have been used before. So this one here has had a breakaway from the frog cable. So what I've done is I've brought the cable back to this end here, made sure that it's soldered across so that both these rails here are bonded together. And then for the frog itself, what I've done is I've soldered a cable onto the inside of the frog, and that will drop down, and then these 2 cables then can come together and go up to the point motor. And obviously what you need to do is just do a continuity test, that is between these 3 rails. That's the rail of the frog and these 2, to make sure they're all you have continuity between them. Well, a couple of days have gone by now and it's been a bit of a slog, but the job is almost complete. All the tracks down, the point motors are in, it's all wired up, and all the accessories have been fitted. Tipping the board on its side, you can now see the Fiddle Yard ladder. In the bottom left-hand corner, the last point has no tracks. Obviously these will go on to the next board, but you can see that I've achieved the aim of managing to get all these the points and the fan of tracks onto the one board, making it a movable module. I've used the terminal blocks that I've mentioned in the past. I think I put together a video of them. These are absolutely brilliant, and you'll find a link in the Show More tab below. And I've also used ferrules to get a better contact with them, as it were, and also ID tags, which is absolutely ideal then for fault finding. And hopefully you can see that the far left-hand cable is labelled FE3, which stands for F for fiddle, E for the eastern board, and 3 because it refers to the 3rd track in. Terminals 1 and 2 are empty because obviously the first 2 tracks are yet to be connected. And so that's the way I've kind of ID'd them all the way through. Obviously the negatives are in the black one, and the positives are on the right hand side with the red bridging piece. The red ones will actually go into a BDO 168 eventually, because that'll go for block detection. And there's the DS64s with the points cables coming in to enable us to switch them. And then there's another one of those similar terminal blocks here, except this one controls all the cables for the points. So as you can see, they're all labelled with their relevant point numbers, and the cables then go from here down into the points themselves and onto the point motors to enable the frogs to be switched. Over on the other side is just the stuff for the BDO168. This is for the block detection on the helix, because there isn't really room for it. But there you can see the guts of the board. And now flipping it over onto its other side, hopefully this will kind of make sense. I explained when I did this very first point that the spool of cable wrapped up is that stuff for the mimic panel, and all the points are exactly the same. The yellow and blue cables go up to the DS64s, which are through those two holes there. And then the massive cables go through there, which are the feeds for the points. And the other terminal blocks on the other side are underneath those holes there. It always looks more complicated than it really is, but it is only just one wire after another. And there, as you can see, the 7-point motors all hopefully raring to go. I've also put the ID tags on the base of all the cables where they come out of the board, so I know which ones are which should there be a fault. And to make the ID tags, I use this Brother printer, and it prints out, well in this case, a heat shrink sleeve, which I then obviously cut up and put onto the cables. It also does, you know, ordinary sticky labels and that sort of stuff. But that's what I've used for this. And for the ferrules, which you can see going in to this connector block, I've used these, and it's a simple device. It's just a set of crimps, and then you get a box of ferrules to go with it. And all the tools I've used today, as usual, will be in the Show More tab at the foot of the video. Well, I hope you found that interesting. I must confess I'm quite proud of the achievement over the last few days. It certainly goes to show that Code 100 track in a used condition, you know, is certainly still very useful, as two of the points are, because they were used as well. If you're a patron and would like a copy of the AnyRail file, then please contact me through Patreon and I'll email it out to you. It might be of use, you know, to help you with your design. But I must thank Lee Stoddard, because he's done a sterling job with his design. It really is top quality. I really couldn't have done it without him. I just don't have that level of imagination. Anyway, that wraps this one up. I'd like to thank my patrons as usual, because they make it all possible. And if you'd like to make a donation, then please do so. Don't forget to subscribe, and there should be a video here and here. See you in a couple of weeks. Take care. Bye-bye.